Hi, my name is Dr. Welcome to today's video about exoplanet news. This is the first exoplanet group that was ever found in 1992-1994 around the pulsar PSR B1257+12. This pulsar is a magnetized rotating neutron star. It is a product of a merger of two white dwarfs. It's at a distance of 2,300 light years and has a mass of 1.4 solar masses. The three planets have a mass of 0.02 Earth mass, and the other two have 4 Earth masses. What's special about this planet is they are second generation of planets. They were formed after the pulsar was formed together. So they did not exist while this pulsar was a star. So that's why they are called second generation. This is the first planet ever around another star, normal star. That's 51 Pegasi b, around the star 51 Pegasi, a distance of 51 light years. It is an older system than the solar system with the age of 6 billion years. The planet 51 Pegasus b has about half the mass of Jupiter. It is just at a distance of 8 million kilometers, and that makes it a hot Jupiter planet. This planet was found with the radial velocity method. These are the types of planets. At the left, these are the gas giants like Jupiter and Saturn. In the middle, in light blue, these are Neptune-like planets. And top right, terrestrial planets. And there's a group between terrestrial and Neptune-sized planets. These are called the super-Earths. In the solar system, there's no such example for a super-Earth, but the super-Earth planets are quite common. The theory for the formation of the hot Jupiters is a migration theory, so they were formed further outside and then migrated to the inner part of the system. Our Jupiter migrated too, but the difference is Jupiter was caught by Saturn and then pulled back out. This is an artist image of the system TOI 4860b. TOI means TESS object of interest. There's a work of J.M. Almenara and colleagues about the system. The star is a M star. This is a small star at a distance of 261 light years. Has about 1/3 the mass of the Sun. The planet is a hot Jupiter with a temperature of 700 Kelvin. These type of planets are rare around M stars. The planet has about 1/3 of Jupiter's mass. Orbital period is just 1.5 days. There are strong tidal forces between the planet and the star. And it could be that this system contains a second planet. This is a picture of the planet TRAPPIST-1b. It is a member of the TRAPPIST-1 system. It contains a cool star, M star, at 40 light years distance. The star is just 9% of Sun's mass, so it's very near the lower limit of red dwarfs. The system contains 7 planets. TRAPPIST-1b is one of those planets with a mass of 1.4 Earth masses. And it is just at a distance of 0.01 AU. 1 AU is Earth-Sun distance, 150 million kilometers. It makes it too close to be habitable. And there's a work of scientist García Muñoz. They researched water loss by photoionization, and they found that the photoionization loss depends on the stellar spectrum. This animation of the system WASP 106 is a massive star, F star, has a mass of 1.3 times Sun's mass. Is at a distance of 1,172 light years. This system has a planet, WASP 106b. This is a warm Jupiter with about almost twice the mass of Jupiter. Again, this is quite close with a distance of just 0.09 AU. Harp's measurements showed that the stellar spin axis and the planet rotation axis are very well aligned. And there's a theory for these warm Jupiters And the theory says they are formed by a slow migration of Jupiter-sized planets towards the inner parts of the system. This artist illustration of the system Gliese 9404 is an M star with 62% of the Sun's mass at a distance of 78 light years. There's a Hardegree survey by Thomas A. Baycroft and colleagues. They found an eccentric planet, Gliese 9404b, is 12 times this Earth's mass, which makes it a Neptune-type planet. Again, quite close at a distance of 0.09 AU, and with an eccentricity of 0.49, that's quite high. This is an artist image of the transiting exoplanet survey satellite TESS. It was launched in 2018. It uses the transit method to find planets. What's special about TESS is it covers 85% of the sky. And the satellite has found over 5,900 candidates. These are all the star types in the universe. There's a sentence that you can use for memorizing the star types. This is it. Oh, be a fine girl, kiss me. Oh, be a fine girl, kiss me. L and T are two of 4 types of brown dwarfs. The most common types of stars are M stars with 85%, K stars with 12%, and G stars like the Sun with 8%. There's a work of Rachel B. Fernandes and colleagues. They made a comparison of photometric and spectroscopic data, and they found no big discrepancies. So this means these two methods complement each other. And a star like TRAPPIST-1, this red dwarf, needs 1 billion years to reach the main sequence. This artist image of the planet 55 Cancri E is a lava planet at a distance of 40 light years. It is 8 times the mass of the Earth, not Sun, sorry. It is at a distance of 0.015 AU. It is tidally locked. There's a work of Charles-Édouard and colleagues. They have 2 models for the atmospheric equilibrium. One model is if this entire planet is involved, then you have a high night side heat flux. Second model is if just the day side is involved, there's fractured magma ocean. This means you have a low night side heat flux. This is a nice exoplanet render. There's another work of Sarah Seeger and colleagues. They propose nitrogen fluoride and sulfur hexafluoride as ideal technosignature gases, because on Earth there are no known processes of life that produce these 2 compounds, NF3 and SF6. On Earth, the concentration of NF6 is 3 parts per trillion by volume, and of sulfur hexafluoride it's 11 parts per trillion. SF6 is known to be a very inert molecule because the sulfur atom is sterically blocked. And another advantage of these 2 molecules is they have unique spectral features. There's another planet around the star 2 mass J04372171 plus 2651014. Planet has a name B. The star is an M star with about 15 to 18% Sun's mass at a distance of 418 light years. The planet is a young gas giant with an age of just 2 to 5 million years. It has 4 times the mass of Jupiter. It is at a distance of 118 AU, which is quite big. And its temperature is 1450 Kelvin. There's a work of Eric Gijs and Teruyuki Hirano. They found carbon monoxide in the atmosphere, and it is possible that the atmosphere also contains water and methane. This planet is a very good target for the James Webb Space Telescope. There's another planet, WASP-31b. It's a puffy hot Jupiter, a distance of 1,305 light years. It's orbiting a massive F star, WASP-31. Its orbital period is just 3.4 days, and its temperature is 1400 Kelvin. And a group with Laura Flagg and colleagues found first time This is the first exoplanet with a chromium hydride in the atmosphere that makes this planet unique. And this planet is also a very interesting candidate for the James Webb Space Telescope. There's another very interesting planet. It's around the binary star system HD 106906 at a distance of 337 light years. This system has a big debris disk, and the planet is HD 106906b with a mass of 9 to 13 Jupiter masses. 13 Jupiter masses means this planet could also be a light brown dwarf. It is at a very far distance of 738 AU. It is not clear how this planet got to this big distance. And what's interesting about the system is that it could give us a hint to find planet 9 in our own solar system if it exists. This is another artist's image of a desert planet. And the question is, if there's a little bit water, could there be a simple life or not? And this is a nice postcard from the system 51 Pegasi P. This planet is also called Dimedium. It is at a distance of 51 light years. That was today's video about exoplanets and news. Thank you for watching. Have a nice day. Bye-bye.